Okay, ladies and gentlemen, this is going to be a little bit longer one, but we can get through this. Remember that standard form, which by the way is given to you right here, of a quadratic is y equals ax squared plus bx plus c. So we give you the equation here. The axis of symmetry can be found very simply by taking the opposite of b. Now keep in mind b is the linear term. We talked about that. The x equals the opposite of b over 2 times the a term. Okay, you're going to see that as we kind of go through this, but just take it for what it is. It's the opposite of b over 2a. Now the vertex is going to be that value, the opposite of b over 2a, because remember the vertex x value is always the same as axis of symmetry anyway. And then plug in x value. So in other words, we're going to find this and then we're going to plug that value in right there and there to find what the y value is for our vertex. We'll see some more examples of that later. The y-intercept, of course, is 0 comma what? Well, if I plug 0 in here and here, they go away, and I'm just left with c. Pretty easy. If a is positive, if this number is positive, like for instance 1, then it opens up, like that. Yay. If it is negative, then it opens down. Yes, I have something fancy for that too. Like that. Now, the parent function, the most basic quadratic, is the parent function, y equals x squared. This, of course, opens up because it's positive in front. Its axis of symmetry, well, if I take the opposite of b over 2a, there is no b term here. So b is technically 0, and 0 divided by anything is still 0. So the axis of symmetry is just x equals 0. The vertex then, now keep in mind, this always has to be the x value here. Sorry, that's 0. When I plug 0 in, 0 squared is 0. That's how I get the vertex. Excuse me, I'm going to keep saying that over and over. The y-intercept, well, it's 0c, so 0. The c, there's nothing, so that's 0 as well. Now, increasing and decreasing. Well, we'll get to that. We've got to, first of all, come here, and whenever you're doing these points, always put your vertex right in the middle. I'm going to put 0, 0 right in the middle. And then just go up by 1 or 2. Okay? In this case, it's easiest to go up by 1. So 1, 2, 3. And let's just plug it in. Right here, I'm plugging it in to the original equation. So 1 squared, 2 squared, and 3 squared gives me 1, 4, and 9. Let's go graph these before we do anything else. Here's 0, 0, 1, 1, 2, 4, and 3, 9 would be somewhere way up there. I'm not going to worry about it. Well, we know from what we've done before that through the vertex it'd be like an axis of symmetry here. Okay, let me just draw that in here actually. This will be my axis of symmetry. So in seeing that, these points should just reflect right here, because I'm 2 over, I need to go 2 over, and then another one way up here. Well, the thing is, that actually is how it works, because if I plug in -1, -2, and -3, well, -1 squared, -2 squared, and -3 squared, of course, gives me -1 times -1, and negative times a negative makes it positive. The negative times a negative makes it positive. The negative times a negative makes it positive. Well, there's my inequality. Excuse me. There's my parabola, excuse me. Where is this increasing? Well, it's increasing, again, from the minimum up, so from x is greater than 0. It's decreasing, well, it's going downhill until I get to the minimum. So it's decreasing, excuse me, when x is less than 0. So far so good. Let's see another example here. X squared plus 3. What does this plus 3 do? Well, first of all, this of course opens up because this is positive. The axis of symmetry, the opposite of b over 2a, 0 over 2 times 0 is just 0, so it's still x equals 0, and again, that point always goes there. If I plug 0 in, because that's what I'm asking you to do for this, is plug 0 in. I plug 0 in up here. 0 squared plus 3 is 0 plus 3, which is just 3. I think the easiest thing to do when you're doing these is to plot that vertex right away. Here's my 0, 3 right there, which of course 0 anything is my y-intercept. Well, it makes sure it says 0c. C is the constant term without an x, so yep, that would make sense. Is it a maximum or minimum? Well, if it opens up, that means it looks like this, well then the vertex has to be the minimum. We didn't talk about that up here, but it's again a minima there. Where is it increasing or decreasing? Well, let's put some numbers in here first. Remember, we put the vertex in the middle. Okay. Go up by 1. Here we go, like so. And plug stuff in. So again, I always think it's easy to plug the positive ones in. 1 squared plus 3, 2 squared plus 3 is 1 plus 3, which is 4. And 4 plus 3, which is 7. Okay, so let's see, I got 1, 4. And I got 2, 7. For the sake of argument, I'll put it right there. Okay. Now again, we know that my axis of symmetry, everything reflects through that. So if that's the case, then this point would reflect right here, and that point would reflect right here. Well, of course it does, because if I plug in negative 1 squared plus 3, I get 1 plus 3, which is 4. And then guess what? Same thing happens here. That should always work that way. Now, I'm not saying that you're always going to get 1 and 2 and negative 1 and negative 2, because that is kind of how it's been so far. We're going to see some problems here in a few minutes that are not going to be that way. Now, where is it increasing? Well, actually, let's connect my dots here first. This should not be rigid. This should be a smooth curve. Smooth curve. I can see it's increasing as it goes uphill from the minima. So from x is greater than 0, and it's really just like this one. And x is less than 0 because when x is less than 0, it is decreasing up until the minima. Okay. Next page. Now, what if a is not 1? Well, it's still solved kind of the same way. Okay. We're going to open, again, up because a is positive. Axis of symmetry is the opposite of b over 2a, which again is still 0 over 2 times 2, which doesn't matter because I'm still going to get x equals 0, which again, that gives me that. The y-intercept is 0b, which is negative 4. And if I plug 0 in here, 0 times that is 0, minus 4, negative 4. They're the same thing there. I'm going to go plot that point. Is it a maximum? Well, if it's opening up, again, the bottom point is a minima. Let's just circle it this time instead of rewriting it. Increasing, decreasing, we'll get to that. Let's put the vertex in the middle again. And 1, 2, probably negative 1, negative 2, right? Because we know where our axis of symmetry is. Let's plug in 1. I get 2 times 1 squared minus 4. Now be careful. Order of operations here. A lot of people want to go 2 times 1 first and then square it. That's not how it works. What we're doing here is exponent before multiplication. So this really is 2 times 1 minus 4. And 2 minus 4 is negative 2. Okay, so I'm going to go plot that. 1, negative 2 right there. Now again, I know this is my axis of symmetry without coloring it in there. I know I can go right there. Well, that's negative 1, negative 2. That makes sense. Again, look, these points should be the same. These points probably should be 2. And rather than plug in a negative, let's plug in a positive. I get 2 times 4 minus 4. Again, exponent before the multiplication. And 8 minus 4 is 4. Okay, so 2, 4 should reflect 1, 2 over. So 1, 2 over again gives me negative 2, 4. And that should be that way anyway. I could show you the math behind that, but why? Well, we know they reflect. We can just reflect the point and be good. Connect my dots. And keep in mind I'm not an artist, so don't judge me. I'm increasing here or here. Think about that a second. Well, we've done it enough time. Hopefully you realize increasing again is uphill. So as x is greater than 0 and as x is less than 0, it's decreasing to that point. It's not always going to be that way. I know it's been 3 out of 3 problems so far, but let's keep going because I think things are going to change here. What if there is a b on this next problem? Well, first of all, this opens down. Why? Because that's negative right there. Okay, and that is my A, that is my B, and that is my C. So when I do my axis of symmetry, again, remember it's the opposite of B over 2A, not negative B over 2A, the opposite of B over 2A. So I get negative 4 over 2 times negative 2, which is negative 4 over negative 4, which is 1. So my axis of symmetry is x equals 1, which again, that point is always the x value of the vertex, and I got to go back and plug 1 in. Let's just do it right here. Negative 2 times 1 squared plus 4 times 1 plus 5. Again, notice I'm plugging in both x's. Has to be that way. 1 squared is 1 times negative 2 is negative 2 plus 4 plus 5 is 2 plus 5, which is 7. So my vertex is at 1, 7. I apologize, this isn't going to fit on the graph as well as I'd like it to. But 1, 7 is probably right about there. The rest of the graph will fit. So I put 1, 7 in the middle again. My y-intercept, I don't know that yet, but it's 0, c. Oh, I do know that. It's 5. If I plug 0 in here and 0 in here, they both go away. I'm just left with 5. Sweet, then I can go graph that too. 0, 5. Now keep in mind, my axis of symmetry is not the y-axis this time. It's the line x equals 1. So if this is a point, well then that sure is a point. And that is at 2, 5. Well, look at what happened here. If I go down, if I go up to 2 and 3, well sure enough 2 worked. If I plug 2 in, negative 2 times 2 squared plus 4 times 2 plus 5, I get negative 2 times 4 plus 8 plus 5, and negative 8 plus 8 plus 5, well of course that's 5. Well, that makes sense. So we know that if we reflect that this should be 5 too, but a lot of people want to try and put negative 2 and negative 3 here. That's not what we're doing. If I go up by 1, I need to go down by 1, and if I subtract 1 and then subtract 1 again, that's what I get. Which makes sense again. If you look at the graph, this wasn't at negative 1, 5, it was at 0, 5. So I get there. I already know, I guess I can circle maxima here, which always happens when a is negative, but you can also see it's the highest point on the graph. Now let's plug in negative 1 or 3. Which one do you think is easier? I think more of you make mistakes with negatives, so I'm going to use 3. Negative 2 times 3 squared, 4 times 3 plus 5. I'm going to do this math a little quicker. 9, negative 18 plus 12 plus 5 is negative 6 plus 5, which is negative 1. So there's 3 negative 1 right there. And guess what? It reflects to right there, which of course makes sense because then it's negative 1, just like I had originally said. Connect my dots. Done. Where is it increasing? This is a little different from what we've been seeing here. I have a maxima. It is increasing to the maxima. Again, we're always reading the graph left to right. It is increasing all the way up till it gets to the maxima. So that's when x is less than, again, the x value of the vertex. And after the maxima, after the top of the hill, you're also going downhill, so you are decreasing from there. So the graph itself is decreasing as x gets greater than 1. Okay? And there's that problem. One more. Yuck, we got a fraction. That's okay. I got a couple of helpful hints for that. First thing, is it open up or down? Hopefully by now you can realize positive, it opens up. You're not going to be asked on a quiz or even on your homework necessarily, does it open up or down? I want you to realize that it opens up or down so that when you graph it, oh, I did this wrong, it's not going the right way. Axis of symmetry, x equals, again, the opposite of b over 2a is negative 2 over 2 times a half, and that's not that ugly because hopefully you know that half of 2 is 1. Okay, negative 2 I get here. The vertex x value again plugs in there. Let's plug in negative 2 in here. This is a little more confusing, but I'll do it here. Squared plus 2 times negative 2 minus 1. Negative 2 squared is 4, and half of 4 is 2, plus negative 4 minus 1, which is negative 2 minus 1, and of course that's negative 3. Okay, so there's my vertex. I'm going to go put it in my chart over here right away. My y-intercept is 0, c. Well, c is negative 1. That's kind of nice. Negative 2, negative 3 is right here. 0, negative 1 is right here. Now remember, the axis of symmetry we said is x equals negative 2. So it reflects 2 over there, then it reflects 2 over here. And I've got 2 points already before I even keep going. Now, is this a maximum or minimum? Well, it opens up, so of course it's a minima. Where is it increasing or decreasing? Well, I'm just going to put x here, and I'm going to put negative 2 here. I'll fix the signs when I'm done. Well, obviously, actually, I know it's going downhill till it's here, so it's decreasing when it's less than. It's going to go uphill. It's increasing when it's greater than. We don't have to wait to fill that in if we know if it's going up or down. Now, what about these points? If you picked, let's just say negative 1, and you square it, you get 1, and then you take half of it, and you got to add fractions to this and fractions to that, and it's going to get really ugly. The helpful hint I will say, I'm going to write it over here on the side, is when a is a fraction, What I want you to do is go up or down by whatever the denominator is. Go up slash down by multiples of the denominator. It will always cancel out real nice for us if we do that. So in other words, if the fraction is 1/2, go up by 2 or even 4 if you want, but just go up by 2s. If the denominator is 3, go up by 3s. If the denominator is 4, go up by 4s, and so on. Stuff will cancel out nicely for you. So I'm going to go plus 2 up here to get me to 0, which again makes sense because I have that point right here, 0, -1. Now could I plug that in? Yeah. 0 plus 0 minus 1 is -1. Oh, okay. Well, then where's the other point reflect here? Right here, -4, -1, which again, these two are the same, and I would go down by 2 there. So guess what? If I go down by 2, go down by 2 again, I get to there. If I'm going up by 2, go up by 2 again, gets me to there. Now again, now I have to plug that one in. That's not one I can just look at the graph and do, but that's not hard. Half of 2 squared plus 2 times 2 minus 1. 2 squared is 4, and half of that is 2. If I did that too fast, that's half times 4 over 1. 4 over 2 is how I got the 2 here. Plus 4 minus 1, 6 minus 1 is 5. And if that's 5, well, that better be 5, but let's go check. 2, 5, right here. It's 1, 2, 3, 4 away. 1, 2, 3, 4 away would put me right here, which is -6, 5. Connect my dots. It's not as perfect as I'd like it to be, but it is what it is. Now, the other part of this is what happens to a graph when the a was a fraction compared to when a was a whole number. Just look at the two graphs. What's different? This is what I would call a skinny graph. This is what I would call, well, maybe I better not say fat graph. I just did. So when a is a fraction less than 1, the graph gets wider. And conversely, when it gets greater than 1, you can see it's going to get thinner. Okay. Now those two are kind of the same, but if you look at the previous page, they weren't that case. Okay. That is today's lesson in a nutshell. The homework is the next 2 pages, 1 through 6. Good luck, and we'll see you tomorrow.